Okay, average rate of change over a specified interval. This is in a precalculus series. There are many ways to find an average rate of change, but bear in mind that a rate of change is really just a slope. So we're going to use the letter m to designate slope, and it's the change in the outputs divided by the change in the inputs. Let's write that down. Slope is the change in outputs divided by change in inputs. It is just a ratio. So keeping that in mind, well, that's what we're going to be using, so of course we'll keep it in mind. This is our outputs, f of the value. On the interval, you know what? This is a little messed up. Typically we'll say a is less than b, so let me change that over an interval, a to b. We generally like to have our, all the time, we want our smaller number on the left, larger number on the right. We usually take our larger number minus our smaller number, so we have positive numbers to work with. It's easier that way. We create less havoc and stress and anxiety and headaches in our life. It doesn't mean negatives go away, but they less often come up. All right, x squared is our function that we're dealing with. And we're going over the interval -1, 3. So we're going to use our formula, f of b and minus f of a. Well, this is our a, this is our b. When we find f of b and f of a, we're going to say f of b, so f of 3 is 3 squared, which is 9. We need to find f of a, which is f of -1. Well, that's -1 squared, which is 1. We have found f of b and f of a. This is f of b and f of a. We know what b and a are. A is -1, b is 3. We're ready to put this into our ratio, our formula for the change in outputs divided by the change in inputs. Change meaning, hey, we're going to find the difference. So we have 9 minus 1 divided by 3 minus -1, which today is 8 divided by 4, which is 2. So our slope, or our average rate of change over the interval -1 to 3 of our function x squared is 2. What does that mean? Well, let's take a look at it on a graph. If we have, I'll just sketch this very quickly, it doesn't have to be quite perfect, x squared. If we're looking for on the interval from -1 to 3, -1 to 3, the slope of that line, or the average rate of change from -1 to 3, well, that's from 1 up to 9 on the range, for the range values or outputs, that average is 2. Meaning the slope is 2. All right, let's move on to the next one. The function x plus 4 divided by x minus 3. Again, change in outputs divided by the change in inputs. We're still using the same function. Let's identify what f of b is and f of a. We'll do this on the side so we make sure that we're not using incorrect numbers. F of b, that's a and b, so 7 plus 4 divided by 5 minus 3. Well, let's see, this is 11 over 2, and oh, my bad. This has to be 7. We're using the same number. This is still b, or x minus 3. So that is 4. 11 over 4. Otherwise it wouldn't work out. Okay, f of a, now we're only using the 5. 5 plus 4 divided by 5 minus 3. Well, that's 9 over 2. Let me make this a little more clear. 7 and 4. We don't need mistakes early on. They would carry through the entire problem. So putting these together, f of b, 11 over 4, minus f of a, 9 over 2, divided by b minus a, 7 minus 5. Well, we've got some fractions in the numerator. We have a denominator of 4, denominator of 2. The common denominator is going to be 4. So we need to multiply this one by 2 over 2 to get a common denominator. So this is 11 minus 18. So 11 fourths minus 18 fourths is 11 minus 18 is negative 7. So negative 7 fourths divided by 7 minus 5 is 2. I don't like fractions in fractions, so let's make this 2 over 1. How do we take this fraction to divide by that fraction? Well, anything time we divide by fractions, we have to change it to multiplication and multiply by the reciprocal of that divisor. So, well, this is the same as negative 7 fourths times the reciprocal of this, 1 over 2, which is negative 7 eighths, and that's our slope. Let's look at this graphically to see if it makes much sense. This graph, see if we have enough room here. Sure. We see that it has a vertical asymptote at positive 3. X cannot be equal to positive 3. We also have a horizontal asymptote at 1 divided by 1 is 1. And the graph is going to look about like this. I'm really interested in the average rate of change between 5 and 7. Well, 5 and 7, if this is 3, 5 is going to be about right here, 7 is going to be about right there. We're looking at the average rate of change, or the slope of this line. That looks like about maybe a little bit less than negative 1 on this rough estimate, and this is just less than negative 1. So we know that we've got this fairly close. We can verify this on a graphing utility. Let's go to our last example. f of x equals 1/2 x plus 5 on a massive closed interval, negative 800 to positive 600. So f of b equals f of a equals, well, this is our a, this is our b being the larger number. F of 600 is, well, 1/2 times 600 plus 5. F of negative 800 is 1/2 of negative 800. We're just substituting the a or the b into our x values, plus 5. Well, 300 plus 5 is 305. Negative 400 plus 5 is negative 395. We're ready. We have a and b. We have f of b, f of a. We're ready to put this into our formula. Our slope is going to be the difference in the outputs divided by the difference in the inputs. Let's go from b to a. So 305 minus a negative 395. And then b to a, 600 minus a negative 800. 305 plus 395 is 700. 600 plus 800 is 1400. This is, we'll cancel out the zeros. 7 over 14 is 1/2. All that work for a slope of 1/2. That's our average rate of change for this equation. Well, let's look at the graph of this equation. It doesn't seem like it's all too strange. If we graph this, this is our slope-intercept of 5, or y-intercept of 5, excuse me, and our slope of 1/2. 1, 2, 3, 4, 5. We'll put a dot there. rise over run, up 1 over 2, up 1 over 2, up 1 over 2. We have a function that looks like this. Continuing on, what is the average rate of change of negative 800 to 600? Well, if we counter that all the way out, we see that it's still on this line and on this line. The average rate of change is parallel, it's right on that line, is going to be 1/2. Well, if the slope of this line is always 1/2, then the average rate of change will be 1/2. We shouldn't have a mystery there.